From last few videos, we're dealing with the different types of the problem related to the frustum of a cone of mensuration mathematics. Here we have another question. A container opened from the top and made up of metal sheet is in the form of a frustum of a cone of height 16 centimeter and radii of its lower and upper ends are 8 centimeter and 20 centimeter respectively. Find the cost of the milk which can completely fill the container. All right, which can fill, it means they're asking about the volume. All right, and at the rate of 20 rupees per liter, and find the cost of the metal sheet used to make the container if the cost is rupees 8 per 100 centimeter square. It is 100 centimeter square, right? So we need to find out first area also, because total material used to make that we need to find out, so that we can find out the cost of the material to make that whole container. And then we need to find out the milk, how much milk it can carry there, so the cost of the milk also we need to find out. So first let me tell you what it is. All right, let's say this is the upper circle of the container. Container is in the shape of the frustum, so I'm trying to make like that. So here is my container in the shape of the frustum, and the information I have got is the height of the cone is 16 centimeter, right? So the height is here 16. Similarly, the radii of the lower and upper, lower radii is R1, let's say is 8 centimeter, and here this one upper one, let's say this is R2, which is given by question 20 centimeter. All right, now as per the question, we have got the lower radius, we have got the upper radius, we have got the height of the container, but we don't know the slanted height of this container. So now let's find out the slanted height of the container, because we may need this in future a lot of time. So to find out the height of the container, we have the direct formula also, but I'm not going to use the direct formula. I'm going to show you in this picture. All right, so I'm going to shift this height here. Okay, so this is height. All right, let me give the name here. Let's say it is A, it is B, it is C, and I need to find out the slanted height, which is actually BC. All right, so what I can write from the Pythagorean theorem, that hypotenuse BC square is equal with the base square plus the perpendicular square, that is AB square plus this AC square. All right, and therefore BC is actually AB square, and the AB we don't know now. We can find out AB easily, because this complete length is 20 and this is 8, this is 8, so easily we can find out that this length is 20 minus 8. Right, this length is 20 minus 8, that is 12. All right, so it's going to be now 12 square plus AC square. AC we know that is 16 square, so it's under root, that's 144 plus 256 inside the root, so it's going to be 400 and it will be 20. All right, so BC equals to 20 centimeter, which is our slanted height. And we used to represent slanted height generally by L. All right, by L. So we got the L also. Now there is nothing unknown to find out the volume as well as the surface area. All right, so let's first find out the volume. Let's first find out how much milk can it contain. All right, so the volume of the container, container is in the shape of the frustum, so the volume will be actually the volume of the frustum. So volume of the frustum we have learned, that is 1 by 3 pi h R1 square plus R2 square plus R1 times R2. So now here 1 by 3, right, and the value of pi, question is saying we need to use 3.14. all right, so let me use here, it is 3.14. height we know that is 16, and R1 that is 8 square, R2 that is here the complete height is 20, right? So this complete height is 20, so it's 20 square, and again R1 that is 8 times 20. Okay, so it's 3.14 into 16 into now 8 square, that is 64, 20 square, that is 400, 8 times 20, that is 160, right, and then whole divided by 3. Okay, so it's going to be now 3.14 into 16 into this 3, and 400 plus 160, that's going to be 560 and 64, 6 to the 12, so it's going to be 624. Let me use the calculator, it will be I think more easier. So it's going to be 3.14 times 16 times 624 and divided by 3, that's going to be 10449.92 centimeter cube. This is our volume. We got the volume, and everybody know one thing, because here we are going to put the milk, so we need to convert the centimeter cube into the liter, and we know that 1000 centimeter cube equals to 1 liter. So therefore, in the place of 1044.92 centimeter cube, I can write 1044.92 divided by 1000, and it will be now liter. So it's going to be 10.445 liter, right? It's 9, so I can remove this. So we got the liter, 10.445 liter, and we know the cost of per liter. 20 rupees per liter is the rate. So the total cost of the milk that we can fill inside this. So cost of milk we can fill inside container is the total milk times the cost. Cost is 20 rupees. All right. So it's going to be 208.9 rupees, or simply we can say it is almost 209 rupees. All right. Now the symbol of rupees is like this also. It's rupees means it's an Indian currency. All right. Just like dollar or pound or euro, it's another symbol. All right. We find out the cost of the milk, and now the next question is saying us also find the cost of the metal sheet used to make the container. So what is the total metal sheet used to make this container? To make this container, we have to find out the curved surface area and this lower surface area, lower circle surface area, because the upper one is empty, from which we need to put the milk. To pour the milk, we have to make this leaf, we need to make it blank, empty. So we need to find out this bottom circles area, and we need to find out the curved surface area. So the material used, area of the material used is going to be curved surface area of container plus area of lower circle, bottom circle. So it's going to be curved surface area. That's the formula for the curved surface area is pi r1 plus r2 into L plus bottom circle, that is pi r2 or r1. Let me see here. Bottom is, we have supposed as r1, so r1 square. All right, it's r1 square. So it's pi, and r1 is our 8 and r2 is our 20. So it's going to be 8 plus 20, and our length we had recently found out, slanted length, that is 20. All right, so it's 20 plus now again pi, and r1 is our 8, so it's going to be 8 square. So finally we get pi 20 into 8, 28 into 20, that's going to be 28 into 20, 28 to the 56, 560, and again 64 pi, and now it's going to be now 560 plus 64, again it's going to be 624 pi, that is 624 into 3.14, which is going to be 1959.36, and its area, so it will be centimeters. We get the total area of the material we need to make this container, and the question is now asking find the cost of the metal sheet used to make the container if the cost is 8 rupees per 100 centimeters square. All right, so here cost of 100 centimeters square metal sheet is rupees 8. So therefore cost of 1 centimeter square metal sheet will be rupees 8 divided by 100, and cost of this much 1959.36 centimeter square metal sheet will be rupees 8 over 100 into the thing that I'm going to multiply 1959.36. all right, I need to multiply it because for the one we have this much, then for almost 2000 we have a lot, so that's why we need to multiply it. And I'm gonna use the calculator. It's gonna be times 8 divided by 100. It's going to be 156.74 rupees, right? This is our answer. This is the cost of the metal sheet we need to make that container. Similar type of a lot of question you need to solve. You try to solve your textbooks questions or the questions given by your teachers. If you have any questions or any things you need to ask about this video, then please feel free to comment below this video, and don't forget to subscribe the channel.